Alright folks, Chapter 4, Functions and Closures. If you've had another programming language like C++, you're probably already familiar with functions, and they operate pretty much the exact same way in Swift. But just don't forget there's always three parts of those, the declaration, the call, and then the function itself. And we'll get into more of that in just a bit. So for those of you guys who have never seen functions before, a function is a reusable group of code. So it's a group of code that you can like pull out and stick somewhere else, and it works and it performs its function. So it has a specific purpose, a specific function, which is why they call it a function. If you've ever learned some of the older programming languages, like you may have heard of it called a method in C# or a procedure in Pascal. But if you look at this math function, fx equals x minus 32 plus 5 divided by 9 converts Fahrenheit to Celsius. So I can use that function anywhere and just plug in the number for x, and it'll convert x from Fahrenheit to Celsius. So that's the same way a function works. It's just a group of code where I can just go plug in some variables and it'll give me whatever I need. So to create a function, we use the keyword func. And then the function name, and then the variable that we could use. There could be a variable name, colon, and then a type, and then the return type. Let's say my function is Fahrenheit to Celsius, so it would say function Fahrenheit to Celsius, variable name, which could be the Fahrenheit value. The type would be integer or float or double. And then my return type would be the same thing. If I put in a double here, so like the temperature is 88.2. So Fahrenheit value is 88.2. It's going to return the Fahrenheit value. Let's say the Fahrenheit value comes back at 12.4. So function says, hey, this is going to be a function. The name of the function, any variables inside the function, and their type, and then what type you expect it to return once the function runs. And then once you have that title bar, then you put your curly braces in, then you can put the actual math or whatever your function is going to do. So for example here's function Fahrenheit to Celsius. I'm going to take the Fahrenheit value, and it's going to be a double, and it's going to return a double. So anytime somebody says Fahrenheit to Celsius and calls that function, it's going to return a double. And they're expecting you to give it a Fahrenheit value. So, excuse me. So now inside this function we create a new variable, and the new variable is going to be called result, and it's going to be a double. And then result is going to be the Fahrenheit value minus 32 times 5 divided by 9. And then we're going to return the result. So when somebody calls this function, they just may say Fahrenheit to Celsius, and then in parentheses 88.2. And that gives us the Fahrenheit value, and then that Fahrenheit value gets popped into here, and then they subtract 32, multiply by 5, divided by 9, and then that becomes the result that we declared here. So that's the return value. So inside your curly braces or curly brackets, whatever you want to call them, you can have any system that you want. It can return strings, it can return variable or doubles or integers or whatever you want, whatever the purpose of the function is. But today what we're really going to focus on is this first line. When you create the function, this creates the function, and then this is what is the function, what the function does. Alright, so now you know how to build a function, and function sits outside of main if you're in C++, but in Swift we typically put the functions at the bottom or something. So now you know how to design a function, but how do you call it in your program? Well, you can call it several different ways, and this is called this is the function call, and we're going to set the value. So here they create a variable named outside Fahrenheit temperature, so outside F temperature, and it's going to be 88.2. And then their next line of code is that the outside F temperature equals Fahrenheit to Celsius outside F temperature. So anytime you see this Fahrenheit to Celsius and then something in parentheses or a value, you know that's going to call the function, and then the function is going to convert it for us. So I copied this wrong. This should be outside C temperature. So if I did variable outside C temperature, it would take the Fahrenheit, pop it in here, and then the function would be called, and then it would turn it into Celsius. So that's what the outside Celsius temperature. So that was just my mistake. This should say outside C temp. Sorry about that. And there's another example of this on 86, but they're a little bit long. It's like outdoor temperature in Celsius. That's too much for me to type because I'm a lousy typist. Alright, moving on. You can also call your function at any time by just giving the function name and then whatever values you need to put in parentheses. So anytime the program sees the function name followed by parentheses, it puts the value in parentheses into the function and then returns the result. And your function can have any purpose. It can calculate Fahrenheit to Celsius, so it can do math problems. It can also return strings and make sentences. So if my function is build a sentence, and then I've got 3 variables and they're all strings. So I have subject, which is a string, comma, variable, which is a string, comma, and then noun, which is a string. So you can have as many variables as you want, just variable and then the variable type separated by commas, and then the return type. It's going to return a bunch of a big line of strings. And then so it's going to return subject plus space plus the verb space, and then the noun, and then the exclamation point. So if I were to type build a sentence and then put Swift is cool as my 3 variables, this would print out Swift is cool exclamation point and put a space between the 2 words. And this works for short things where you only got a couple of values. But what if you have a function that's going to compute 50 different values or something like that? The last thing I want to do is write value 1 integer comma value 2 integer comma value all the way to 50. That would be kind of miserable. But I can do this and have double and then 3 dots, and that tells me that every variable there's going to be more than one variable. So Swift can use that parameter to signify multiple variables. So let's say the function just adds all the numbers. So the function add my balances, and then my balances are going to all be doubles, and then it's going to return a double. So if I ran add my balances, it would take 10 plus 15 plus 24 plus 21 plus 15. Or if I did add my balances, it would take 10 plus 56. So a lot of times, if you don't know how many values the user is going to input, you want to do something with the 3 dots. And I believe that's called variable parameter passing notation. Ooh, say that 10 times fast. You may want to have a function that adds or calculates a tip value, but you don't know how many values somebody's going to put in. What if, hey, the 5 of us just had a meal. She brought us all individual receipts, but we're going to pay for it in one lump sum. So how much of a tip do I put it in? So I would do like add my balance, and I would put in all those different amounts, and then the function itself would generate a tip for me. So you get the idea. All right, so moving on. Functions are first-class objects, which means they're treated like a regular variable. So whatever you can do with a variable, you can typically do with a function. Like you can have multiple variables, you can have multiple functions. You can have a variable that is another variable. You can have a function inside a function. You can have a function call a function. So again, it's just they're treated just like a variable. Alright, and then moving on, I tell you to open Angel. In class we do this, and then you paste the next code. I have included the code from page 92. And it starts at the bottom of page 92, and then it runs over to page 93. But if you're at home, just open up your book to page 93, and if you look at that screenshot, it shows you the output from that. And again, I have included the code in Angel this week. So the code looks like this. So I'm creating variables account1 and account2. So then real quickly, I got 2 functions. I have the deposit function and then the withdrawal function. So the deposit function is going to take an amount and an account name, and it's going to return a name and a balance, or a double. So, and then it takes the new balance is going to be the account balance plus the amount of the deposit, and then it's going to call that the new balance. So pretty self-explanatory. Same thing with the withdrawal. So new balance is the old balance minus the amount they withdrew, and then that becomes new balance. So then they get a little tricky here, and they make money transaction equal deposit. And remember, deposit is the name of our function. So now whenever we type in Monday transaction, it's going to be converted to the word deposit, and deposit's going to call this function. So then we say, hey, let Monday balance equal the deposit function, because remember we changed the name, and then 300 in account 1. So whenever I run this, it's going to take $300 into our account, into account 1. And then the same thing for Friday. Friday is going to be named withdraw, and then on Friday we're going to withdraw $1,200 from account 2. Make sure as you're going through this with your book and stuff, you can go through this line of code and decide what everything does. Now, you don't have to get tricky and take one variable and change it into the function name and then call that variable later on. That's more for readability and stuff later as people are learning things, that kind of stuff. As long as you had, let Monday balance equal deposit and then 300 in account 1, that would be fine. So at this point in the game, I'm not worried about you being tricky, but I do worry that you make sure that you understand each of these lines of code and what it does. So again, this is an Angel. If you want to cut and paste this into a playground and screw around with it, you can. You can also see the comments on page 93, what it would show on the right side. Alright, and then in the interest of being tricky, here's a function returning a function. So this is function choose transaction. So now I got to pick what kind of transaction I'm going to do. So it's going to accept a name that's going to be a string, and then a value that's going to be a double, and it's going to return a string and a double. So remember in the code that we just looked at, if I put this at the bottom, if transaction equals deposit, run the deposit function. Else it's going to return the withdraw function. Ooh, and I just realized that I funked up this whole string here. So my transaction is going to be a string, but then it's going to return all this other stuff, and I'll go over that here in just a second. So the transaction is just a word, and that word will either be deposit or withdraw. So choose function, so I can do choose transaction space deposit, and then this would run, and then deposit would run, and then that would return the word deposit, so it would run the deposit function. Now, hopefully we won't see anything like that this semester, but when you get into the iOS 2 class, you may start building bigger programs that call other functions. Alright, let's talk about this line here, this string double blah 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 blah. Alright, so function, choose transaction, whatever word we're looking for, deposit or string, and then it's going to return a double, and that double could be a string and a double, and a string and a double. So the return type is a function that takes a double and a tuple with a string and a double, and it returns a tuple of a string and a double, if that makes any sense. So that's the big long technical blah 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 for it. But if you see it in another context, maybe that'll help. So if I'm calling that function, so I do let my transaction equal choose transaction deposit. So remember, if I do choose transaction deposit, that's going to go to the choose transaction, and it's going to say, hey, do you want to do a deposit or withdrawal? And because I have deposit in these brackets, it's going to run the deposit. So now the deposit function is going to run. So after this last parenthesis, it's now going to run the deposit. And then when the deposit runs, it's going to take 225.33, and it's going to deposit that in account 2. So that's a function wrapped up in a function, or a function calling a function. So when you're asking yourself, well, where would I use this? What if you were making a banking application on the iPhone, and then you had a field where it said, is this going to be a deposit or a withdrawal? And what's the amount going to be, and then what's the account name it's going to go into, and then somebody fills out all three of those and hits the button. Well, when they fill out all three of those, it would fill in this deposit, number, and account, which would run all the other functions. So eventually we're going to write some code where people put different items in boxes, and it's going to execute a function on our iPhone or our iPad. So just be aware, that's how this is all going to kind of tie together. So from the boxes, it fires off, it fills in these statements, and then those statements fire off the functions. So then one more example, choose transaction is going to be withdrawal. So it's going to go to the choose transaction, which is going to say, hey, he typed in withdraw, so deposit is false, so I'm going to run the withdraw function. Then the withdrawal function is going to subtract $53.17 from account 1. So that's kind of how it all works out together. So that's a function calling a function, but you can actually have a function inside a function. So here's an example. So function bankVault. And I'm going to have a passcode, and that's just going to be a string. And my return type is going to be a string. And then I've got two functions inside there. Open the bankVault or close the bankVault. And they are both going to be void. They don't need any value, but they're going to return vault open or vault closed. Now this example is on page 96 and 97 of your textbook. So, and then it's going to say if passcode equals secret, which is our secret password, it's going to return bankVault open. So it would just say the vault is open. And if the passcode was not secret, it would say vault closed. So you can see the rest of the code on page 97, but you get the idea. So you can have functions inside functions. And a function doesn't have to calculate anything. It can just return a string. So let's say you're writing a math tutor program. A student types in his answer. Is his answer right or is his answer wrong? Well, a function inside a function would be a good way to say, is his answer this? Well, no, then that needs to return the function, your answer is wrong, please try again. And if his answer is right, hey, good job, your answer is this, make sure that you, wrote down your work. Something like that. So sometimes we're not doing math functions or calculations, we're just returning a string, we're just returning something to the user so they know what happened. So a function can have any specific purpose. The problem with functions are a lot of times as new programmers we try to do too much with a function. Just remember, anytime you have the word and, if you try to say it in English and you have the word and in there, it's probably going to require two things, or two things to do. Like if you're going to step through an array and see if each variable is prime number, then that's going to require two functions, one to step through the array, and then one loop to step through the array, and then another loop to compare everything to see if but I think I've already used that before. Just make sure you kind of keep that in mind. Alright, so some other things to keep in mind. The functions openBankVauult and closeBankVauult are functions inside the function bankVault. So they can only be used in the function bankVault. And they cannot be called from outside of bankVault. So they're not in scope. Other languages typically refer to this as local. They're local to that function. So these two functions are created and declared inside bankVault. So they're only available inside bankVault. Anywhere outside the program, they're not accessible. So make sure you're aware of that. If you ever put a function inside a function, that function can only be used inside the main function. So we typically refer to a function inside of functions as nesting functions. We have nested loops, we have nested functions, you get the idea. Alright, so what if you don't know what the parameter is going to be? Well, what if I don't supply a parameter? What if you want to set one, that should be one, of the parameters to always be the same? The textbook uses a check writing program where the function will always use the same person's name as the payee, and that's on page, it starts on 99. So if a user does not supply a parameter, what parameter do you want to display? That's a default parameter. So here's an example. So the check writing function, so here's the function, it's going to write the check. And it's going to say, hey, the first variable is going to be payee, and it's going to be a string. If it's not supplied, use the word unknown. And then create the amount, which is going to be the second variable, and that's going to be a string. If it's not supplied, it's going to be $10,000. And it's going to return a string. And then return check payable to unknown for $10,000. Now, if I could call that all three ways. I could do write check, nothing. And this would say check payable to unknown for $10,000. Or if I did write check payee Donna Donut, it would say, check payable to Donna Donut. Wow. Because I did supply the name for $10,000. Or I could do all the stuff, write check, payee Joe Donut, amount $45,000, and then it would say check payable to Joe Donut for $45,000. So that's where those default parameters come in. if possible, you typically want to put some kind of default parameter in there because you never know what kind of input the user is going to put in. It's going to say, give me a number between 1 and 10, and they're going to put in 11. It's going to say, give me a number A through E, and they're going to put in Z. They're going to do all kinds of stupid stuff. So you always need to have some kind of check in case they did not put in the right information. But you also want to have a way around if they don't put in the information. Sometimes they just hit return to see what's going to happen. So always have that default value in there if possible. Alright, and then for reading things and making things more clearly when people are reading your code, you can use optional external parameters. So you get the idea. So function write check from pair string to payee string. So I can put the from and to in there, and it's not going to affect anything. And then when I call it, I can do write check from Joe Donut to Sandy Cheeks. So the English is a lot better. It makes a lot more sense. So that's obviously much more readable than something like write check. Well, actually, that's not too bad. But you get the idea. I guess if I was writing a letter, that would make more sense. But we all get the idea. All right, then your book covers like a shorthand method. So we could start with from pair string to payee string, and then we could go to pound sign, or in your case, hashtag pair string, hashtag payee string. And then we could just call it with, write check from Joe Donut. And that would write a check and just put Joe Donut as the from person, and then put the default value in the to, unless you have something else there, or that you created a default value. Wow, did I really funk that up? But you get the idea. Me personally, I like the from and to because it makes it a lot more easier to read. The hashtag thing, like when they're both hashtags, I don't know, it doesn't work for me. Alright, moving on. So functions are prohibited from changing the values of parameters passed to them. So if I send a value to the function, the function can't change that value. It can use that value to fill in a new variable, like it can take the 88.2 and convert that to Celsius and now make that the new Celsius variable, but it can't change the 88.2. The Fahrenheit value will always be 88.2 inside the function because the function is not allowed to change that. So the way we get around that is we create temporary variables inside the function to allow us to change that 88.2. And then that's covered starting on page 105, where it says, don't change my parameters. But so inside the function, I can take that Fahrenheit value equals 88.2, and then say my temp value equals Fahrenheit value, and then I can manipulate the temp value inside there because the temp value didn't come from outside. It was created inside the function, so it can be changed in the function, if that helps. But that kind of you understand. Alright, you can also change the value of a parameter in a function and then send it back out to the main program in its new changed form using the in-out. Alright, and this is mentioned on page 108. I don't think we'll be messing with that too much. Thank goodness. But if you ever need to change a variable, you get the idea. Alright, so now closures. Now, a closure is very similar to a function, only they don't typically have a keyword or that name like a function has. So another name for a closure is a lambda. And all variables and constants declared and defined before a closure are captured in that closure. So a closure looks something like this, and so it doesn't need a keyword. You just have the curly braces, then you have your parameters, your return type in, and then statements. So it's like a nameless function. So for closures, there's no keyword. Like a function has the keyword function. Closures don't have a keyword. So in this case, here's a function that calculates the simple interest. So let simple interest calculator equals, and then everything here in the brackets is the closure. So loan amount, which is going to be a double, and then a variable interest rate, which we create inside the closure, is going to be a double, and then the year, which is going to be an integer, and it's going to return a double in. And that's going to take the interest rate times 100%, and you get the idea. So the closures start on page 109, and it ends like 2 pages after that, and then that kind of wraps up the chapter. So a closure is just a small block of code, it wrapped up in curly braces that doesn't have a keyword to signify it. A function has func this and func that, and then the name. Where closure doesn't have that. We can have any kind of name, and we can just do let, or we can do variable, that kind of stuff. And then anytime I need to do some kind of interest calculation, I can just take this block of code and kind of move it to my new program. So it's kind of like, don't reinvent the wheel, just reuse what you've got. Alright, looks like that wraps up this week's chapter. You got an easy week this week. You're going to write a function that converts yards to meters. Then you're going to write a function that will compute a 15% tip on the amount somebody puts in there. And then I may come up with one more function, but if not, you're going to have those two functions that I first talked about as your lab, and then you may have that last one. We'll see. So other than that, remember, if you have any questions, let me know. And remember, at this case, I'm not worried about you being all stylish and really getting tricky. Just make sure that you can write a function and that you know how to call the function. Other than that, if you got any questions, make sure you guys email me. And don't forget about my office.